Alright, so I decided to create a hyperbola in this equation. We have to have the focus on the origin, so we must have our center must be the x-axis with no shift up or down. So I decided to use the a, b, and c values of 12, 5, and 13. So since c is the distance from the center to the focus, our focus is at the origin, and our focus at the origin, the center must be at negative 13. So as you can see, that's our c value right here. So our center is at negative 13. Since we know the center and the a and b values, we can create the hyperbola since the a is 12 and the b is 5. So we can create x plus 13 squared over 144 minus y squared over 25, because this is a, that's b, this is the center, h and k, but there's no k value for this, equals 1. So we have to put this equation in polar form, which is this equation right here, e times k over 1 minus e cosine theta equals r. So E is the eccentricity of the hyperbola, and K is the vertex to focus and the vertex to directrix added together, like those distances added together. To find the eccentricity, we must do C over A, which is 13 over 12. And K is, like I said earlier, the vertex to directrix plus vertex to focus. And the eccentricity can be also found by doing that point to directrix over point to focus over point to directrix. So we can set up the proportion of C over A equals PF equals PD. So we know C over A is 13 over 12, and we know the distance to the distance between the vertex and focus is 1. So we can solve this proportion, and we end up getting PD equals 12 over 13. So PD and PF added together is 25 over 13, and we get the equation R equals 12 over 13 times 25 over 13 over 1 minus 13 over 12 cosine theta, which, after multiplying everything by 12, we get 25 over 12 minus 13 cosine theta.